Hello students, today's agenda is a check homework. We're going to be learning about rational and irrational numbers, and you will be able to work on 1.4. Today, students will be able to respond to questions related to rational and irrational numbers. But before we do that, we're going to have to review some things that we learned in the module. And so it's about the number sets. And we have the counting numbers, or also called natural numbers, and it just starts from 1 and you count up. It's like counting tables. You're not going to count starting at 0 or negatives, right? You just start counting 1, 2, 3, 4, 5. And so the symbol for natural numbers is N, for counting numbers is C. Okay? Whole numbers is similar to natural, but it includes the 0, and the symbol is W. Okay, so these are almost the same, but this one includes the 0 and natural numbers don't. Integers include from the negative infinite to positive infinite, and it has 0 in the middle. Okay, so -3, -2, -1, 0, 1, 2, 3 will be kind of like in the number line. Okay. After integers, we have rational, and rational numbers are numbers that can be written as a fraction or as a ratio. And so those are fractions, and it says in here all of the above, because all of these can be written over 1, and that's a ratio. Okay. We also have repeating decimals, like 0.3333 comes from dividing 1 by 3, which is 1/3. Or 0.666666 forever is 2/3. 0.5 is the same as 1/2. 0.125 is the same as 1/8. So repeating decimals or terminating decimals come from fractions, actually, and that's why they are part of the rational numbers, because they are numbers that can be written as a ratio. Irrational numbers are numbers that are non-repeating, non-terminating decimals. What does that mean? That if you find the value, for example, of pi, 3.1415926, etc., 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 it'll continue forever without repeating. Same thing for the square root of 2, for example. If I press here 2 square root, 1.414213562. So it has no repeating pattern after the decimal point. Or the square root of 3, 1.7320508008, etc., etc. So it doesn't have like a repetition. For example, if I divide, let's do the 2 divided by 3 is the 0.66666666, so it repeats. Or the terminating decimals, which is 1 divided by 2 is 0.5. It doesn't have any numbers after that. It's just 0.5 and that's it. Okay. 1 divided by 8 is 0.125. It's 1/8. So that's kind of like, that's a fraction actually, and so that's why it's a rational. But these are numbers that do not repeat. Also, I have the example here, and I guess I can explain it again. The square root of 20, if we simplify, even if we take the square root of 20 right now, it's going to be 4, oh, it doesn't have it in here. It's going to be 4.477213, etc., etc., etc. But there is no repeating decimal, so that means that it's an irrational number. Now, how I simplify this is we do prime factorization. Then the 4 is 2 times 2. It says to group it in 2, and I send the 2 here, the captain. This is lonely, so it's going to go down here. When you cannot simplify anymore and you end up with a root in the simplification, that means that it's going to be irrational. Okay, now there are some that might look like irrational. For example, square root of 4. We already know that the square root of 4 is 2, because 2 times 2 is 4. You send the captain there. And so the answer is a whole number. 2 over 1 is a rational number, okay? So be careful. It's only when you cannot simplify to a whole number that it's an irrational number, okay? Okay, having said that, this is a review from one of the modules, but looking at this, are these rational or irrational? That one you can just put it over 1, and that's a ratio, so it's going to be rational. This has this etc., 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 or continues on. It's 3.1415926. That's pi, actually. Okay, that's the first couple of numbers for pi, so that's irrational. There is no pattern in the decimal part. Square root of 16, you can use your calculator or do prime factorization if you would like, or you might know already that the answer is 4, so this is rational. Remember, irrational only non-repeating and non-terminating decimals, okay? Square root of 98. Actually, before I even press that, let's do it on the side. Square root of 98. So here is 2 times 49. 7 times 7. Since the index is a 2, that means that this is a pair. You send out the captain, but then this doesn't have a pair, it's lonely, so that's going to stay inside of the square root. Just because you cannot simplify to a whole number, that's a square root, so that makes it irrational. But you can even see in here, you get 9.89494937. So there is no pattern in there. There is a lot of 9s, but it doesn't repeat. Okay, and then this is just a terminating decimal, so that's gonna be rational. In fact, I can tell you that it's gonna be, and from the previous lesson, it's gonna be 5 over 2, because 5 divided by 2 gives me 2.5, or there might be others, but that's the simplest one. Okay, so we have a closure property here, and the closure property for irrational, and well, it says when you multiply or add 2 rational numbers, the answer is rational. And also when you multiply or add a rational with an irrational number, the answer is irrational. Okay, I'm going to give you at the end a summary of what this means, but I'm going to give you examples first just to make sure that it makes sense what we're saying. Okay, but if we multiply or add 2 rationals, then the answer is rational. If we multiply 1 and 1 rational with 1 irrational, the answer is irrational. Okay, let's look at these examples. Oh, and before we do that, I can't remember if I pointed out that for the rational and irrational, that's very important because I'm going to be using those. So for integers is z, for rational is a q, and for irrational is an I. Okay, so we're going to be using q for rational, irrational, I for irrational. Okay, so let's identify this as either rational or irrational. So the first one is a fraction, so that's going to be rational. The second one is also a rational number. The answer, we just multiply straight, so 1 times 1 is 1. 3 times 2 is 6, and we cannot simplify, that's a fraction, so it's going to be rational. Okay? In here, because it doesn't continue, it doesn't have the 3 little dots that says and on and on and on. So it's 0.83 times 0.5. So it's going to be 5 times 3 is 15, carry 1. 5 times 8 is 40, and 1 is 41. Okay, I just multiply this times this, and then this times this. Okay, and so I count that after the decimal point is 1, 2, 3 spaces. So I'm going to go back 1, 2, 3 spaces. So that's rational, and that's rational. In here, this is rational and this is rational just because they are fractions. And so in addition, I use the butterfly. So it's going to be 1 times 7, 7. You might be reviewing some of your fractions. Plus 3 times 2 is 6 over 2 times 7 is 14. I add the numerator part, and so it's 6 plus 7 is 13 over 14. And I can see that the answer is a fraction, so that's rational. When adding, and I guess just as a review, I'm going to put them in here. You have to line up the decimal points, okay? And so in here, basically, it's a 0. So when you add, you just add 9 plus nothing is 9. 1 plus 2 is 3. You bring down the decimal only once, and 3 plus 2 is 5. So the answer is 5.39. It's terminating, it doesn't continue. So this is a rational because it's terminating, rational because it's terminating, and rational because it's terminating. Okay? So that fulfills the first closure property that it says when you multiply, or add two rational numbers, the answer is rational. Now let's look at the next set of numbers. We're going to need a little bit of help here. So the square root of 2 is 1.414213, etc., plus 1.7 equals, so the answer is 3.1142135, etc. This is irrational just because it's a number that has non-terminating, non-repeating decimals. This is terminating, so that's a rational number. But this is a non-terminating, non-repeating, so that's irrational. For the next one is 5 plus square root of 2. This is a rational number because you can put it over 1 and that becomes a fraction. The 2 is irrational. We already learned that from here. And so 5 plus square root of 2 equals 6.41421356, etc. That's irrational as well. I don't see anything repeating in there. And by repeating, I mean like it would be 414, 414, 414. You know, like it will be the same pattern. In here we have a rational and we have an irrational. So 5 times square root of 3 equals 8.66025403. Hopefully I'm not eating some numbers. And so that's irrational because it has repeating, non-repeating, non-terminating decimals. The next one, 3 times square root of 2 equals 4.2426406, etc., etc. So we have a rational, irrational, irrational. So notice when I'm adding one rational with one irrational, or multiplying one rational with one irrational, again adding irrational with rational, irrational with rational, at the end the answer is always irrational. Okay, I was gonna say something else about the calculator. Yes, so some calculators you're gonna have to first, when you're doing the square root, notice how I press the number first and then press the square root, and it gives me the answer for that square root. For some calculators, you're gonna have to press first the square root, then the number, then adding, etc., etc. Okay, and I guess I should have done one with this one, but yeah, check which one works for your calculator, if you press the number and then the square root, or if you press the square root. I think it opens as parentheses, so you might have to close a parenthesis as well. Okay, they open it for you, but then you have to close it before you add or subtract. Okay, don't forget to close it. And if not, you can always come and I can help you with that. Okay, so in here, well, 24 is an irrational number, and I'm going to write down the number here, 4.89897994, etc., etc., etc. What about the square root of 26? It's 5.0990195, etc., etc., etc. And so when I put those together, I just wanted to show you that those were irrational. But what if I add them, and I'm going to add the actual square root of that plus the square root of 26 equal 9.997998999. Oh, I put one too much, one too many. So that's irrational. And what about square root of 3 is irrational. Square root of 24, we already saw that is irrational. So the answer is square root of 3 times the square root of 27 equals 9. So that's actually a rational number. Okay. And did I do this one? I think I did this one right here. 3, or the square root of 3 times the square root of 24 equals. That's different. So that's 8.4485281.3, etc., etc., etc. So no, that's irrational actually. And that serves well because then this is 9, and so this is the same, irrational. This is irrational, but then the answer is actually a rational answer. So what can we say about this? Well, I have a page with the summary. Noticing here from the beginning, if we're adding or multiplying two rationals, the answer is rational. If we're adding or multiplying 1 and 1, the answer is always irrational. But when the two of them are irrational, then that's when we cannot tell. Sometimes it's going to be irrational, sometimes it's going to be rational. So this is the table that I created. Hopefully we can see it. Let me see if I can zoom in so you can see it all. And so when you're adding two rationals or multiplying two rationals, the answer is rational. When we're adding or multiplying 1 and 1, the answer is always irrational. But when we are multiplying or adding two irrationals, we cannot know. The answer might be irrational or rational. Okay, so that's it. Now you can work on 1.4 and have fun.